Hello everyone, my name is Osherove. This is test review number 3. Today we're going to review, that's right, Microsoft Unity. Now, Microsoft Unity Application Block is another project that's been released as open source by Microsoft. You can download it on Codeplex. Before we get started, just want to talk a little bit about the fact that I'm the author of the book The Art of Unit Testing, coming out hopefully soon. There are several things to say about the tests in the Unity source code. First of all, in regards to the way they're organized, just want to show you their test organization and to say it's actually pretty good. And overall, I was pretty impressed with the test. The quality of the test is very solid, very mostly readable tests. There are some, places here and there which I'll cover which are a bit problematic. But overall, I think the quality of the tests in Unity is pretty good. There may be not enough tests, maybe less than 500 is my count. But anyway, let's look at the way it's built. First of all, you can see that there's the solution for Unity. There are the solution items. And there's a source, and they chose to put a folder called tests, and instead of saying unity.test, they wrote test.unity and so on. So it's okay as long as you have a naming convention and you're consistent with it and everyone knows where to find whatever it is they're looking for. That's good, and I'm happy about that. We'll talk about some mixing stuff up later on, and the things I'm going to show are all over the source code. The first thing I want to show is this. If you've never seen the ignore attribute, the ignore attribute means this test is actually skipped. And here's the thing, ignore attributes are a big smell. They're basically saying there's a bug that we know about, and this test will fail. So we're ignoring it. That's the same as deleting the test. It's a big yellow sign that says something's wrong. As far as I'm concerned, I don't like to ignore tests. They either pass or they fail. If they fail, it's either not in the source code or we make it pass before the build. Releasing like this with skip tests, usually bad form as far as I'm concerned. Because not that it technically is a problem, but I think if we look at it from a team structure point of view, the team knows that now there are holes that you can just ignore and continue on. When in fact, what I want my team to do is to have full personal integrity on the source code. It says everything in the source code passes. There's no such thing as it's okay that this fails, because that's what ignore really means. Let's move on to the next thing. What I see a lot of people do, and this is actually pretty normal, this is a test that all it does, you can actually see they wrote this comment here. Now this is my comment, and I'll explain it in a second. They wrote this comment here: experimenting with reflection and open generics. Oi, what a pain. I'm guessing maybe that's Glenn Block who wrote it. I don't know. Who knows oi? Except a couple of Jews somewhere in Seattle. However, it's important to notice there is nothing to do with Unity here. This is purely understanding how reflection works, and I think that's great. I think using tests as a form of exploring things is a great idea, because you basically let your thoughts run and you do the asserts where you think they are. Since this is not a real test, this is what I call an exploration test or exploratory testing. Well, not I call it, someone else called it way before me. I just don't remember the name, sorry. I think it's perfectly okay and reasonable to have experimental testing or exploratory testing. I just don't like it when those exploratory tests are jumbled up inside regular tests. So what I want you to do is to put these exploratory tests in a separate class, actually says exploration test or something like that, so that whoever sees it knows that these are just things to make you understand the system better, or someone wrote them to figure out how stuff works and so on. But these are tests that usually can break a lot of the regular ways we write things. For example, you can have multiple asserts just to make sure things are okay, because you have much less confidence about how things are. So exploratory tests, okay, just put it in a different folder, put it in different namespaces, something that makes them different. Another thing that I found in several places, the issue of magic numbers. Again, it's amazing how prevalent this problem is. Now, magic numbers, I don't have a problem with hard-coded numbers. I have a problem with magic numbers. What's the difference? Magic numbers are numbers or strings, for example, that you have no idea why they exist or what they're supposed to mean. What does 37 mean? Just imagine the poor guy who needs to read these tests. Where does 37 come from, right? You have a proxy, set pipeline, get method, but number 37 appears from nowhere. Do something probably puts it in A, but why does 37 get put in A? More importantly, why exactly 37? Why not 36? And I know it sounds a bit ridiculous, but whoever wrote this test said, you know what, let's just put 37 in there. And that's silly. The reason it's silly is because whoever reads these tests is just going to wonder, even for a second or 5 seconds, say, does 37 really mean something? Now, there's also this magic string here. Now, I want you to pay attention to this test. There are several asserts here. That means that we're testing several things here, but this is actually an assert that's not needed in this test. How do I know it's not needed? Because I've reviewed the test before. There are many places where people use the idea of call counts. So either this is not needed, this line, or these two lines are not needed, because only a single bit of these two selections is the end result of something. So either the out and ref works, and that's what I'm testing, or it actually gets called once by some call count handler which is used in the test. Now look at the name of the test. Ref and outs are properly handled. Now that's a big problem, because properly handled in this case actually means that they can be set and that they are called, that they're called or something. Properly handled doesn't mean anything. You either say what's supposed to happen because that's what you're asserting, or because you have a hard time naming it, maybe that means you're testing multiple things. If you're testing multiple things, there's always a chance you have multiple asserts and only some of them pass, some of them fail, but you only know about the first ones that fail, because that's a partial view of stuff. And I've explained this in previous videos. I won't take a lot of time to explain this here. So maybe the test is testing too many things. Maybe someone just didn't pay attention. Okay, next. That's another example of exploration testing, jumbled right inside the code. Okay, reflection over property type returns properties. Someone tried to learn how to do reflection properly, and that's great. That's really, really great. Because you put these in a separate class and you show people how things are done basically. How do you work with reflection and so on and so on. Yeah, it actually reminds me, someone asked on the previous videos, what's that yellow thing behind me? And no, it's not a big banana. It's actually a surfboard. And I know it sounds weird that there's something that actually supports my weight, but yes, it is a big surfboard, and maybe in next videos, if you're nice enough, I'll show you my surfboard. And I know you're not expecting that in the test review video, and there are a lot of things you're not expecting, but feel free to do the same thing at near 1 a.m. at night. And for those of you who are wondering why I'm doing this at 1 a.m. at night, because I don't have enough time, you bastards. Let's see what else we have. Okay. Can intercept wrapped object with ref. Okay, what can intercept? Probably the interception fixture. I don't know what can intercept. The test name is pretty bad. But what really, what I really had a problem with is this. Somewhere there is some sort of hard-coded stub class that has a method ref. Now if we look inside the code, It puts magic strings and magic numbers in many things. Now remember, I already explained that this is a big problem for the test reader, because test readability is very, very important. Why is this a problem? The first reason is that whoever reads the test has no idea where foo came from. And second of all, this can only be used with tests that expect these values. So you cannot even reuse that code that you worked so hard to create. What you really want to do is to have the test always configure what's the string that's going to be put on. So for example, method ref here, foo would be set into some public property that was set by the test. I would actually put here what to output as ref, which will be a public property, right? Includes public field or whatever. Let's make it public. I don't even need to make it a property here. Why do I need to make it a property? Because it's a stub, it's part of the test. I don't need to add extra logic to it. And then in my test I would actually say wrappable what to put as ref equals foo. And then my test becomes much more readable. And I also can reuse it for other tests where maybe some other string might create a different result, and so on and so on. Now they tried to do this by putting in a variable name called foo. That's not enough. Again, remember, it's not reusable, and that's my big problem with it. Okay, this is a very interesting example of in Unity there's a lot of configuration work that's being tested. So what they did is they have a whole test.unity.configuration, and they have a whole lot of config files along with CS files. So the minimum thing I would expect is to put the config files in a separate folder that's below this, or the CS files in a separate folder that's below this, because otherwise I need to go and look what's what, and that's very, very annoying. So remember, do not annoy the test reader, especially if that test reader has a blog and does video reviews. It also raises another interesting question. When you have config, do you want to test with actual config files? Because that makes tests much harder to write, because you have to write custom utility classes that set up the app domain with the custom config file that you just wrote. Or do you want to stub out the configuration file or the configuration reader? Both are okay. In this case, they actually chose to use the real config files, and I can understand why, because these are actually sort of integration tests, so you need file related stuff. I would actually love it if they renamed test.unity.integration.configuration. There are other tests here, by the way, not just configuration, that could be well served by being named as integration test, and we'll go over them. Also, because this is using MS Test, every config file that's being used is actually, they have to put in a deployment item that's going to be copied into the test directory where MS Test runs it. If you were using NUnit or MBUnit or whatever, you wouldn't have to do this, because it would just run on the code as is. Let's see what else is interesting. Okay, this is another problem for test readability. Look at the test name. Type element uses alias, and then there is a using type creator, which is part of the actual test class. This is like a helper, and you give it a config name, and then you create an instance configuration proxy, and then you say proxy type element uses alias. There is no assert here or whatever. So apparently what happens is that all the asserts are inside here. So at the minimum, okay, remember, if you have hidden asserts inside a utility method, start them with a standard name. If there are asserts in there, I usually start with either verify underscore or assert underscore, so that all methods that have asserts in them start with the word assert. It's very easy on the eyes, very simple to understand. Just look at the code here. The configuration section fixture proxy actually has a lot of asserts. Just look at all the asserts here and just highlight them. Okay, so there are a lot of asserts going on here, a lot of assumed information, and so on. Some of it is hard to understand. At the minimum, I would expect the name of the method to start with assert or verify, so that makes the test much more understandable. Now, type element uses alias. Okay, I can understand this because it's being used here, but again, this is really problematic. I actually had a hard time understanding what the test is, and I had to go into the method to see if there's something else. Remember, every layer of indirection that you put in the tests just causes a little more confusion to the test reader. So make things in the test as readable as you can, as open, as specific as you can. No guessing, least surprise factor. Everything should be as simple as possible. Here's an example where people add asserts that are not really needed. Because we're asserting that the types count is equal to 1, there's no need to check that this or this is not null. Because if I'm checking that both of these are not null, if one of them was not null, I know this assert would not pass. Look at the test name. Config file can specify container without a name. I'm not sure if this is actually needed. Not sure. Look, C2 is taken from here, and it's never used. Only C is being used. I have no idea why C is actually here. And you know what? Neither will the test reader or test maintainer. So the test maintainer will never remove this. You know why? Because when you don't know what the code does, you don't touch the code, right? You don't touch it. And this test will maybe at some point in the future this will fail, and people think the test is not okay. But in fact, this is the only thing that matters. This is the assert that really counts. So remove unnecessary asserts if you don't need them. Okay. Can specialize generic types. It was really hard for me to understand if the register type method is being tested or the resolve. One of them is the one that contains the logic. So that's why I usually start my test method names with either resolve, the method under test, if there is one under test. So resolve. And that way I know that resolve is the one that contains the logic under test. This was really missing for me. Again, this is another example of can set lifetime to singleton. Who can set lifetime to singleton? Where is the object under test here? Is it TE lifetime? Is it get unity section? Is it the section from configuration? This is configuration related stuff. This is a test that uses threads. Look at the name, the place where it's located. It's under tests.unity, which we think is unit testing. Then it says container controlled lifetime threading fixture. Now, fixture, the word fixture at the end of the class is a remnant of the old times where people used to say everything in a class is just a X fixture, class fixture. But usually I just call it test class or configuration tests as the name of the class. But the fact is, this uses threading. And once you introduce threading, you're not really doing any testing. Because threads are something you don't have control over, which means you're doing integration testing. Even if it's not touching the file system, it's using threads, you automatically make your test a bit harder to maintain, harder to read, harder to run, maybe longer to run, and so on. So this should be in a separate folder or project under integration tests. Now, I wrote what the fuck here, and the reason is I don't like people using short notation in tests. Tests are about readability, so why the fuck are you doing this? Why are you forcing me to start parsing this code? Can't you just say if this then return 500 else? I know some people can read this with their eyes, their eyes closed or something, but come on, just assume, this is a tough enough problem as is with threads and so on. Just make it as easy as possible to read stuff. Don't assume that the reader knows everything. Assume they're always having hard time reading stuff. This is an example where people put a lot of asserts just to make sure things work, but they really only care about some of the things. For example, maybe this should be a different test, because these two asserts, here's another example, these two asserts are testing the same thing. O1 and O2 should be the same, so why are you testing the opposite one as well? Assert R equal to that the value's length is correct. This is not really needed, but maybe this should be a different test. Why should it be a different test? Because if this fails, these will never run. These could be true, I don't know. Now remember, this could be over specification. Maybe the first two should be equal, but later I could add functionality that there are actually more than two things in the array. Who cares? As long as the first and the second are the same. That's the functionality I'm testing. So that's sometimes the difference between small overspecification and test that just needs to be maintained when you change things. Here's a test that gets something from something and checks it's not null. And that means absolutely nothing. It just means you get a non-null. You could be getting garbage back. This test means nothing. Delete it. This is a test that's very misleading because of the name. Can specify lifetime for type, and then you have a helper method called test for expected actions under lifetimes. Now this is under configuration section, and this is actually, I'll explain it. I'll show you the code, and if you can figure what this does, I'll salute you. Someone wrote this, so they're saying, yeah, I got it, but always assume nothing about the reader. It took me a while to figure out that this is actually an assert that whatever is in here is located inside the configuration file under this section. So the names of this and this should be much better and actually say, assert expected actions appear in config file section. That would make things much easier for me to read and understand. Next, this is a try catch where you expect an exception from this, and if you get it, then everything's great. If you don't get it, you do an assert.fail. There are cleaner ways to do this. There is expected exception attribute that you can put here, and you can write helper classes in NUnit and MBUnit. You have special helper methods that say assert throws that will take a delegate, and you can just wrap this line in the delegate and say this line should be throwing an exception. Much clearer to read, much simpler code to write. So learn how to do this. Expected exception is one of the most abused features and the worst written. Okay, that's it for Unity for now. Just the things that I found are not that horrible. The quality of tests overall is pretty good. I think that it's not as great as the MVC one, but so far it's actually pretty good, and I'm happily surprised that some of the tests from Microsoft are actually pretty good. The worst ones so far were the Nerdino runs. MVC was great. This is actually pretty good. Hopefully it will not just go downhill like this. Until next time, my name is Roy Osherove. I'm the author of The Art of Unit Testing. You can read my blog at icrealizable.com. And if you want to send or suggest a project that you want me to review its unit tests, feel free to send it to roy@osherove.com with the subject, test review, and the project name. Until next time, cheers guys.